All right, so there's a question about detecting holes with the MLG's connection over IO link from scratch and also blanking. So what we're going to do is we're going to blank out the bottom and I'll blank out the top as well. And then anytime there's no holes, we won't detect it. We won't detect when there's a hole in front of it. So the ones I'm using right now are a different part number in this, but the question I was asked about was 1214337. So a couple things we need to know is communication. What do we have? So we've got two digital outputs here. I've got these set up with a splitter here. So what it is you have from the receiver side, you'll have two cables. You'll have an 8-pin and then a 4-pin. The 4-pin will be Ethernet. That is just for setup, and then the 8-pin cable will go to the T connector. And then you'll have another 4-pin cable or 5-pin coming from here, and you go this T connector, and then mine is a 5-pin out, but I think the one that you've got is an 8-pin. So since we're just using discrete signals, that'll be pin 4 off of the 8-pin connector out of the receiver. So we're looking at Q1 here. And if I put that to the side and I bring up this connector, that's the 5-pin. This is the 8-pin connector. So you'll see the sender it's here, the receiver that's here, and then the 4th pin will go to pin 4 coming out to your PLC, depending on what cable you have. So that's how the wiring is going to look for just powering the devices itself and connecting that side of it. So pin 1 will be hot, pin 3 is not, or neutral, and then we'll just use pin 4. That's only 3 conductors you had to wire up. So now we've got those connected. We can come to SOPUS. If you don't have SOPUS already, you can come to the Downloads tab. And then once we're at the Downloads tab, you come to Software. And then there's SOPUS Engineering Tool at the bottom under Software. So you just download it's free software. You don't need to log in or anything like that. So I've already downloaded the software. And once I open it up, I've already been connected. I've already factory reset these. The IP address of my computer is 192.168.1.29, so I'm on a different subnet. So I'll show you how to change that. So once SOPUS has found the device, and I'm connected over Ethernet, I'll just drag that over. And it's going to tell me I have a bad IP address. So I'll just go to auto and it'll look at my subnet and pick out an unused one. Now it's asking for a device driver. I'm going to go ahead and delete this since we've set a new IP address to it. I'm going to do another search. Now that it's found the new IP address, I'll just drag that over. And it's telling me I need a driver. So I'll do a device upload. Now we've got the device driver. We'll go ahead and just take the sensor online. We'll read parameters and just double click on the icon. We don't need a login. So now it's going to go through the setup function of teaching it. Right now my alignment's not very good. I'll see if it'll go ahead and maybe it'll go ahead and teach for me. These are bars indicating how well your signal strength is or your alignment. So try to get those as close to 100% as possible, but they don't have to be exact. I'll just go next, and it gives me a teach successful. Then I'll push finish. Now the next thing I'm going to do is go ahead and put it in expert mode, and then we're going to come down here to teach in. And what we want to do is go ahead and we'll enable, we'll block the beams. So now we got to talk. We'll go ahead and mute those because we don't care about those beams. It looks like I missed a couple in between my hand there. I'll mute all of them again. Now it doesn't care about anything up here. So just to show that, right now it's showing 74 beams blocked. If I was to move everything and teach in, or muted all block beams, now you can see I've got 119. But if I put that in the way for the muting purposes and cover the top of it, and then mute all the beams, now it doesn't care about what's down here. So the next thing we'll do is go to our digital output. And since we are doing presence of holes, and then we'll say we want to take any hole bigger than one beam. So right now it sees more than multiple beams. You see over here it sees 76 beams, so that is larger than one. Now if I block all of them, it goes off. But you see I've got a hole here. As I block all of them, when I see that hole, then I should trigger that output. And then when I'm blocked, I don't see anything, nothing's on, and it triggers output. If we want to, we could invert that signal so that it would be on in a good state. In case the machine was powered off or something like that, it would always be off for the sensor value line. And then if I put the hole in there, it's off and it's on in a good state. So now I've got all that set up. We'll just come to our PLCs, and I've already got this wired in. PLC programs up, and I've got it on the 11th bit on the input card. I'm not going to change any of this. We'll just see this go on and off. So now it should be on. It sees no holes. As it comes through, it sees a hole, and I can take that back, and we can minimize that as well so that we see the SOPAS interface. And you'll see the output now is in correlation with the other one. Once it sees a hole, I've got my discrete signal. That's it. Let me know if you have any questions. I hope this helps.